Question 1. Calculate the volume of H2 gas at NTP obtained by passing 4 amperes through acidified H2O for 30 minutes is. We give 4 options over here. So H2O gives us H2 plus of half of O2, which is 2H plus of 2E, which gives us H2. So for the production of 1 mole of H2, 2 mole of electrons, that is 2 farad charge is required. So 2 Faraday is equal to 2 into 96,500 Coulomb charge liberate. So therefore H2 equal to 22,400 ml at NTP. Therefore 4 into 30 into 60 Coulomb charge will be liberated. Therefore H2 equal to 4 into 30 into 60 into 22,400 upon 2 into 96,500, which is equal to 835.6 ml, which is 0.836 liters, which is our answer. Matches is option D. Therefore option D is a correct answer. Question 2. 9.65 Coulomb of electric current is passed through fused anhydrous magnesium chloride. The magnesium metal thus obtained is completely converted into a Grignard reagent. The number of moles of Grignard reagent obtained is. We give 4 options over here. So we have W is equal to Z into I into T, where Z is equal to equivalent weight upon F, which is equal to 12 upon 96,500, which is I into T equal to 9.65 Coulomb. If you have W is equal to 12 upon 96,500 into 9.65 gram equal to 12.10 raised to minus 4 gram. So we have 24 gram of magnesium, which is equal to 1 mole of magnesium. Therefore 12 into 10 raised to minus 4 gram of magnesium is equal to 1 by 24 into 12 into 10 raised to minus 4 mole, which we solve it further, we get as 5 into 10 raised to minus 5 mole, which is equal to answer matches option C. Therefore option C is the correct answer. Question 3. How many atoms of calcium will be deposited from a solution of calcium chloride by a current 25 milliampere falling for 60 seconds? We're giving 4 options over here. Given current I equal to 25 milliamp, which is equal to 0.025 ampere. We have T equal to 60 seconds, and Q, we have formula for Q, that is I into T, which is equal to 60 into 25, which is equal to 1.5 coulombs. So number of electrons is equal to 1.5 into 6.023 into 10 raised to 23 upon 96,500. When we solve this, we get 9.36 into 10 raised to 18. So we have calcium, which get dissipated as calcium 2 plus of 2 electrons. So 2 electrons are required to deposit 1 calcium atom. So 9.36 into 10 raised to 18 electron will be used to deposit 2, which is equal to 4.68 into 10 raised to 18, which is, we see our answer matches the option A. Therefore option A is the correct answer. Question 4. A current of 96.5 ampere is passed for 18 minutes between nickel electrodes and 500 ml solution of 2 mole nickel nitrate. The molarity of solution after electrolysis would be, we're given four options over here. Moles of nickel nitrate in 500 ml of 2 mole of nickel nitrate is given as 2 into 500 upon 1000, which is equal to 1 mole. So charge equal to 96.5 into 18 into 60, which is equal to 104,220 coulombs. So nickel 2 plus will gives us 2 electron, giving nickel. So 2 into 96,500 C deposits 1 mole of nickel nitrate. So therefore will deposit 104,220 upon 2 into 9650. Solving this further, we get 0.54 mole. So moles of nickel nitrate left is equal to 1.0 minus 0.54, which is equal to 0.46 mole. So thus the molarity of nickel nitrate solution is 2 into 0.46, which is equal to 0.92 mole. Therefore, our answer matches with option B. Option B is the correct answer. Question 5. The molar conductivity of sodium acetate and HCl at infinite dilution in water at 25 degrees Celsius are 91 and 426.225 centimeters square per mole respectively. To calculate the molar conductivity of hydroacetate, the addition value required is, we give four options there. According to Kohlrausch's law, the molar conductivity of an electrolyte at infinite dilution is the sum of the conductivity of its ions. Therefore, to obtain the hydroacetate from the conductivity of sodium acetate and HCl, the conductivity value of NaCl, that is also needed. Therefore, molar conductivity of sodium acetate plus HCl minus of NaCl, which is equal to, solving this, that is further we get over here, it's minus over here. Therefore, we get this as H plus, which is equal to hydroacetate. Therefore, NaCl is a correct answer. That is, molar conductivity of sodium chloride is a correct answer. Question 6. The electrochemical cell stops working after some time because we are given four options. Electrode potential of both the electrodes becomes 0. B. Electrode potential of both the electrodes becomes equal. C. One of the electrode is eaten away. D. The cell reaction gets reversed. In the electrochemical cell, the potential difference is created. Cathode is at a higher potential and anode is at lower potential. Current flows due to potential difference from higher potential to a lower potential. The electrochemical cell stops working when potential difference is 0. That is, both the electrode potential becomes equal. Therefore, option B, that is, electrode potential of both the electrodes becomes equal, is the correct answer. Question 7. The tendency of an electrode to lose electron is known as, we give four options. A. Electron potential, B. Reduction potential, C. Oxidation potential, and D. EMF. The magnitude of electropotential of a metal is a measure of its relative tendency to lose or gain electrons. That is, it is measure of relative tendency of undergo oxidation or reduction. That is, undergo oxidation, lose of electrons, and reduction, gain of electrons. Therefore, M plus any minus this is oxidation, and for this is N plus of Ne. N is the number of electrons, and this is reduction. Therefore, option C, that is oxidation potential, is the correct answer. Question 8. What is the correct nearness equation for reaction taking place in the following cell? Given over here, we're given 4 options over here. So MgS, that is gives us Mg2 plus aqua, Cl minus aqua gives us Cl2 of gas at 1 atmospheric pressure. The oxidation of cell reaction can be written as Mg plus of 2E, and the reduction, that is Cl2 plus of 2E, gives us 2Cl. So the net cell reaction, that is the total reaction, which we get as Mg plus of Cl2, Mg2 plus of 2Cl minus. So nearness equation can be written as E cell equal to E cell minus of 0.591 upon N log Cl square Mg2 plus, which is, we see our answer matches the option C. Therefore option C is the correct answer. Question 9. When compared to Gibbs energy, that is delta G, for the formation of Al2O3, the delta G for the formation of Cl2O3 is given 4 options over here. Al acts as a good reducing agent and reduces oxides of metals like Cr, that is chromium, iron, and manganese, etc. Therefore, chromium oxide plus of aluminium, that gives us chromium Al2O3 plus of heat. Therefore, Gibbs energy, that delta G for the formation of aluminum oxide is lower in the comparison to delta G for the formation of chromium oxide. Therefore, option C is a correct answer. Question 10. The reaction is spontaneous if the cell potential is, we're given 4 options over here. So EMF is equal to standard reduction potential of cathode minus of standard reduction potential of anode. So where if EMF is positive, then the reaction is spontaneous. For example, in the galvanic cell, EMF is equal to 1.1 volt, where B is a cathode is made of copper and C, anode, is made of zinc. So EMF is equal to 0.34 minus 0.76, which is equal to 1.1 volt. Therefore, we get the positive answer. Therefore, option A is a positive answer. That is a correct answer. Question 11. Given standard potential cell E0 of iron is minus 0.036, and for Fe2 plus is given as 0.439 volt. The value of standard electrode potential for the change given over here will be, given 4 options over here. So for Fe3 plus of 3E gives out Fee. So the Gibbs energy will be delta G1, which is equal to minus 3 into F into E0 Fe3 plus Fe. So for Fe plus 2 plus of 2E gives us Fe. So delta G2 gives us minus 2 into F into E0 Fe2 plus of Fe. And for Fe3 plus of E, the return will give us Fe plus 2. So we get delta G is equal to delta G1 minus of delta G2. So we get delta G is equal to 3 into 0.36 farad minus of 2 into 0.439 into farad, which we get as minus 1 into E0 Fe3 plus of Fe plus 2 into F. Therefore, for the solving, we get E0 Fe3 plus Fe plus 2, which is equal to 2 into 0.439 minus of 3 into 0.036, which is equal to, for the solving this, we get 0.878 minus 0.108 equal to, we get as 0.770 volt, which is we see option, our answer matches option C. Therefore option C is the correct answer. Question 12, for the electrochemical cell M plus and X minus X, we have given standard potential cell for M as 0.44 volt and for X as 0.33 volt. For this data, one can reduce that option. There are given 4 options over here. For the given cell, the cell reaction is derived as follows. That is, for reduction, X plus of E gives us Xe, and for oxidation, so let this be 1 and this be 2. So adding both, we get M plus X, which is M plus of X minus. The cell potential we have as 0.11 volt. Since E cell is negative, the cell reaction derived above is not spontaneous. In fact, the reverse reaction will occur spontaneously. Therefore, B is a spontaneous reaction. Is the correct answer. Question 13. Copper ion is not stable in aqueous solution because of the disproportionation reaction. E0 value for disproportionation of copper is, we given standard potential cell for copper ion. So the required reaction is Cu plus plus Cu, which gives us 2Cu plus. Can be obtained by using the following reaction. So Cu plus plus of electron gives us Cu plus, that is E0 Cu plus plus of Cu given as 0.15 volt, and for Cu plus plus of 2 electrons gives us copper, which is we have as 0.34 volt. Let this be equation 1 and this be equation 2. Multiplying 1 by 2, we get 2Cu plus plus of 2 electrons is 2Cu plus. Let this be equation number 3. So therefore the Gibbs energy we get as, we substitute the value, we have F into 0.15. Therefore Gibbs energy for Cu plus plus of 2E minus of Cu, we have delta G2 equal to minus Fe equal to minus 2 into F into 0.34. Let this be equation number 4. Therefore, further solving this, we subtract 4th from 3. We get this as Cu plus plus of Cu and 2Cu plus. If you see over here, that is third and fourth. So we get delta G3, that is Gibbs energy, minus NFE equal to minus 1 into F into E0. So we get delta G3 equal to delta G1 minus of delta G2. We substitute the value, we get minus 1 Fe 0 equal to minus 2F into 0.15 minus of 2F into 0.34, which we get E0 is equal to minus of 0.38. This is the value for the reaction, that is for Cu++ plus of Cu, which we get as T2Cu plus. So for the given reaction is just reverse of it. So E cell for the given reaction can be written as plus of 0.38 volt. So which is, we see our answer matches with option D. Therefore option D is a correct answer. Question 14. Zinc solid plus Cl2 at 1 atmosphere gives us zinc 2 plus of 2 Cl minus. E cell of the cell is 2.12 volt. To increase E, we give 4 options. According to Newton's equation, we have E cell equal to E0 cell minus of nRT upon F log of C1 upon C2. So for zinc at solid state gives us Cl2 1 ADM, which gives us zinc of 2 plus, so 2 Cl minus. So for C1 is equal to zinc 2 plus and C2 is equal to Cl minus. Hence to increase E, C1 should be decreased and C2 should be increased, as zinc should be decreased and Cl should be increased. Therefore option B is the correct answer. Question between the restoring of iron takes place as follows. So we are given standard potential, that is plus 1.23, and for this we are given minus 0.44 volt. Calculate the Gibbs energy for the net process. So we can write the reaction as, we can write the net reaction, this is delta G, let this be delta G1, and for this 2H plus 2E plus of half O2 H2, let this be, which is in the liquid form, let this be delta G2, that is Gibbs energy. The net reaction can be written as FeS plus of 2H half O2 H2O, let this be G3. Therefore applying delta G1 plus of delta G2 equal to 3. For the solve this, we get substituting minus 2F into 0.44 plus of minus 2F into 1.23. Therefore this can be written delta G30 equal to 2 into 96,500 into 0.44 plus 2 into 96,500 into 1.23, which is equal to delta G30 minus of 322,310 joules, which we get as minus 322 kilojoule, which is, we see our answer matches option A. Therefore option A is the correct answer. Question 16. E cell 0.78 volt for the following cell. We give it over here. For standard cell potential for Fe iron, we have 44 volt, 0.44 volt, and for copper we have minus 0.34 volt. So given 4 options over here. If the solution contains 2 or more cations, the cation to be deposited on the cathode is the one which has higher reduction potential. If the reaction will be Fe plus of Cu2 plus case of Fe2 plus of Cu. So E cell is equal to standard potential cell minus of 0.0591 upon N log of V2 plus upon Cu2 plus. For the solving this, we had 0.78 equal to 0.78 minus of 0.591 upon N log of Fe2 plus upon Cu2 plus. Further, we can write this as log of x upon 0.001, which is equal to x is equal to 0.01 equal to 1, which is we see x is equal to 0.01, which is we see option, we answer matches the option B, that is 0.01 morality is the correct answer. Question 17. Corrosion of iron is essentially an electrochemical phenomena where the cell reaction are. We give 4 options over here. Fe gives out Fe2 plus of 2 electrons, that is anode reaction, and for O2 we have 2H2O plus 4E, which gives us 4OH, which is cathode reaction. So the overall reaction can be written as 2Fe plus of O2 plus of 2H2O gives out 2Fe plus iron hydroxide. So iron hydroxide may be dehydrated to iron oxide or further oxidized to FeOH3 and then dehydrated to iron rust, that is Fe2O3. Therefore, option A, that is iron is oxidized to Fe2 plus and dissolved oxygen in water is reduced to OH, is the correct answer. Question 18. Aluminum oxide may be electrolyzed at 1000 degrees Celsius to furnish aluminum metal. Given atomic mass as 27, 1 Faraday is 96,500 coulombs. The cathode reaction to prepare 5.12 kg of aluminum metal by this method will require, give 4 options over here. So 27 gram of aluminum is obtained by passing a current of 3 into 96,500 coulomb. 1 gram of aluminum is obtained by passing a current of 3 into 96,500 upon 27 coulomb. So therefore 5.12 into 10 raised to 3 gram of aluminum is obtained by passing a current of 3 into 96,527, which can be written 3 into 96,500 upon 27 into 512 into 5.12 into 1000, which is equal to, for the solving we have 1.83 into 10 to the 7 coulomb into 3, which is equal to 5.49 into 10 to the 7 coulomb. So therefore we see option A, our answer matches option A, therefore option A is the correct answer. Question 19. The mass of a copper deposited from a solution of copper sulfate by passage of 5 ampere current for 965 seconds is, we given 4 options over here, given for molecular weight also. So current I is given as 5 ampere and time is given 965 seconds. We know that the equivalent weight of copper can be written as molecular weight upon valency, which is equal to 63.5 upon 2, and quantity of electricity passed in coulomb is equal to current into time, which is equal to 5 into 965, which is equal to 4,825 coulomb. Since 96,500 coulomb will be deposited 63.52 grams of copper, therefore 4,825 coulomb will be deposited, which is equal to 63.5 into 4 to 5 upon 26,500 into 2, which is equal to 1.5875 grams. For this, we see answer matches option B, therefore option B is the correct answer. Question 20. A solution of salt of a metal was electrolyzed for 150 minutes with a current of 0.15 amperes. The weight of a metal deposited was 783 gram. The equivalent weight of the metal is, we give four options over here. Time t is equal to 150 minutes given, which is equal to 9,000 seconds. Current I is given as 0.15 ampere. So weight of a metal, that is W, is given as 0.783 grams. So we know that Q is equal to I into T, which is equal to 0.15 into 9,000, which we get 1,350 coulomb. Since 1,350 coulomb of electricity will deposited 0.783 grams of metal, so 96,500 coulomb of electricity will be deposited as 0.783 into 96,500 upon 1,350, which is equal to 55.97 grams, which we see answer matches the option A. Option A is a correct answer. Question 21. 4.5 gram of aluminum at mass 27 is deposited at cathode from aluminum ion solution by a certain quantity of electrical charge. The volume of hydrogen produced at STP from H plus ions in the solution by the same quantity of electrical change will be. We give four options over here. Equation of aluminum is equal to equation of hydrogen. 4.5 gram (27 by 3) equal to electron of hydrogen, that is 4.5 upon 9 is equal to of H2. Therefore 2H plus of 2 electron gives us H2. Therefore equation of H2 is equal to number of moles into n factor, that is 0.5 equal to n of H2 into 2. Therefore we get V of H2 equal to 0.5 by 2 into 22.4. That is, we get V of H2 as equal to 5.6 liters, which is our answer matches option C. Therefore option C is the correct answer. Question 22. The resistance of 0.01 sodium chloride solution at 25 degrees Celsius is 200 ohms. Cell constant of conductivity cell is 1 per centimeter. The equivalent conductance is, we are given four options over here. We have lambda is equal to K into V, where we substitute the value of K, that is 1 upon R into 1 upon A into V, which is equal to 1 upon 200 into 1 into 10,000. Further solving, we get 5 into 10 raised to 2 per ohm centimeter square, which is, we see our answer matches the option A. Therefore option A is the correct answer. Question 23. The standard redox potential for the reaction given over here are minus 1.18 volt and 1.51 volt respectively. What is the redox potential for the reaction? We give 5 options over here. So we have Mn ion with 2 electrons giving us manganese, where the Gibbs energy, that is delta G, is given as minus Fe, which is equal to 2.36 farad. For Mn plus 3 ions, where electron required we get as Mn2 plus. So adding equation 1 and 2, where we take this as 1 and this as 2, we get as Mn3 plus of 2E of manganese. So delta G, that is gives energy as 2.36 farad plus minus of 1.51 farad, which is equal to 0.85 farad. So we get as delta G minus of N f of E cell. Solving this, we substitute the value of delta G, which we got as 0.85 farad equal to minus 3 into F into E0. Therefore, we get standard potential cell E0 as minus 0.28 volt, which is we see our answer matches with option C. Therefore, option C is the correct answer. Question 24. The EMF of the cell zinc ions is 0.01 mole. For iron, it's 0.001 mole. At 298 Kelvin is 0.2905. Then the value of equilibrium for the cell reaction is, we give 4 options over here. So for the cell reaction, zinc plus iron gives us zinc 2 plus of iron. Therefore, E equal to, we can write this as E0 minus of 0.0591 upon N log C1 C2. For the solving, we have E0 is equal to E plus 0.0591 upon N, which is log C1 upon C2. Therefore, substituting the value, we get 0.02905 plus of 0.0591 upon 2 log 10 raised to minus 2 upon 10 raised to minus 3. For the solving this, we have 0.32 volt. Therefore, E0 is equal to 0.0591 upon 2 log of Kc, which where log Kc is equal to 0.32 into 2 upon 0.591, which is equal to 0.32 upon 0.0295. For the solving, we get Kc is equal to 10 raised to 0.32 upon 0.0295, which is, we see our answer matches with option B. Therefore, option B is the correct answer. Question 25. Small quantities of solution of compounds Tx, Ty and Tz are put into separate test tubes containing XYZ solution. Tx does not react with any of this. Ty reacts with both X and Z. Tz reacts with X. The decreasing order of the state of oxidation of the anions X, Y, Z is, we give 4 options. Oxidizing tendency is inversely proportional to electrode potential. That is Tx, no reaction. Ty, X comma Z, and we get Tz reaction as X. So order of electrode potential is Ty less than Tz less than Tx. So order of oxidation of anion is Y greater than Z greater than X. Therefore, we see our answer matches with option A. Option A is the correct answer. Question 26. For the feasibility of redox reaction in a cell, the EMF should be, we give 4 options. Any redox reaction will occur spontaneously if the free energy charge delta G is negative. That is, gives energy equal to minus of N Fe. So where n is the number of electrons involved, F is the value of Faraday, and E0 is the cell EMF. So delta G can be negative if E0 is positive. Therefore, option A is the correct answer. 27. The specific conductivity of normality or 10 kCl solution at 20 degrees Celsius is 0.0212 per ohm per centimeter, and the resistance of cell containing the solution at 20 degrees Celsius is 55 ohm. The cell constant is, we give four options over here. We have K equal to 1 by R into cell constant, where we can write this as K into R, which is equal to V multiply it, that's 0.0212 into 55, which is equal to 1.166 per centimeter, which we see our answer matches option A. Therefore, option A is the correct answer. Question 28. Aluminum displaces hydrogen from dilute HCl, whereas silver does not. The EMF of a cell prepared by combining aluminum and silver is 2.46 volt. The reduction potential of silver electrode is 0.8 volt. The reduction potential of aluminum electrode is, we given four options over here. Aluminum displaces hydrogen from HCl, but silver cannot. It means aluminum is situated above the silver. Hence, aluminum will act as anode and silver will act as cathode. Therefore, E0 cell is equal to cathode minus of anode, where we get this as Ag minus of therefore substituting all we get 2.46 equal to 0.8 minus of L3 plus A. For the solving we get Al as minus 1.66 volt, which is, we see our answer matches the option D. Therefore option D is the correct answer. Question 29. The hydrogen electrode is dipped in a solution of pH is equal to 3 at 25 degrees Celsius. The potential of the cell would be, therefore we give four options over. Reduction of potential of hydrogen electrode can be given as EH is equal to minus 2.303 of RT upon F, which is log of 1 upon H plus. So in this we get as 0.059 of pH, which is, we substitute the value of pH, we get minus 0.059 into 3, which is equal to minus 0.177 volt, which is, we see our option matches with the answer matches with option B. Therefore option B is the correct answer. Question 30. What is the cell reaction occurring in Daniel cell? We give four options. In Daniel cell, copper zinc galvanic cell, that is galvanic cell, the spontaneous chemical reaction between zinc metal and aqueous copper to sulfate is conducted so as to obtain the available chemical energy released in the form of electrical energy. Therefore we see option B is the correct answer.